Hello, my name is Jessica Seslow, and this is my project for GEOG 778. I created a website application to explore the topic of agroforestry. I worked with the Savannah Institute, a nonprofit that provides resources and education on agroforestry to provide data and scientific guidance on my project. In return, I assisted them with sourcing environmental data related to agroforestry and creating a prototype visualization related to the work. My website application is built with Esri's Experience Builder. I chose the Experience Builder because my project was originally going to be an Esri story map, but I wanted to break up the scroll into more segments and pages. I was surprised to see the Experience Builder is a pretty robust website builder that incorporates Esri web maps and layers efficiently. Staying within the Esri world of products is useful for this project because I'm sharing my data, analysis, and visualization with the Savannah Institute. For my demonstration, I will walk through the pages of my website. I bring up the problem in context. How does agroforestry provide benefits in Wisconsin? I define agroforestry, the intentional integration of trees and shrubs into crop and animal farming systems to create environmental, economic, and social benefits. So scrolling through this page, what does agroforestry look like? And I give examples. These are cards, so we can hover over and get more information. Scrolling down, what are the benefits of agroforestry? And I look at these benefits in terms of environmental, economic, and social benefits, and I discuss information about each of them. So how can we measure environmental benefits of agroforestry? There are really infinite ways to measure environmental benefits, but for this analysis, we are after data sets that have clear and measurable environmental impact and are easy to compare against agroforestry. So another way to think about this is, what can we measure about agroforestry? This is protection from wind, heat, soil erosion, flooding, or provide and supporting habitat diversity, biodiversity, diversity of nutrient use in soil, and carbon sequestration. And for next steps, I talk about the Savannah Institute, and I say check out the Process, Data, and Results tab to view how the rest of the analysis goes. So I'll go to the Process page, and here I talk about the different steps I did for the analysis. So first was deciding the scope, and I did that with the Savannah Institute. We decided, although they're interested in looking at this topic throughout the United States, we're going to keep the analysis to Wisconsin just to limit the scope. And then for choosing environmental data, I actually created a large list of sources for the Savannah Institute to use. We chose the Wisconsin Department of Natural Resources Ecological Index and data from the Soil Survey Geographic Database, or SURGO. And then for the agroforestry data, the Savannah Institute recommended looking at chestnut agroforestry species. And then to compare the data, we needed to project all data into the same coordinate system before analysis, aggregate cells of data into HUC-12 watershed units for comparison using zonal statistics for count, mean, and standard deviation, using the USDA cropland layers locations as a mask. For the SURGO layers, we wanted to limit analysis of these areas to those of existing agriculture, and then joining all of these tables into the same shapefile for analysis. And presenting the results, I have two different summaries shared as web layers on ArcGIS Online. And on the Data tab, I have visual presentations of what these raster data sets look like. And if I scroll down a little, bullet points describing them. So the cropland CDL layer shows locations of existing agriculture. The chestnut suitability index shows locations where chestnut species are suited to grow. And I have data from Surgo that shows where soil is susceptible to water erosion. And then also from Surgo, where soil is susceptible to wind erosion. And for both of these layers, we masked the layers with the cropland dataset because we wanted to limit the analysis to existing croplands. If we scroll down, I presented the mean suitability of chestnut tree species. So this is that suitability index per watershed. This is a graphic that I made with ArcGIS JavaScript. This is a way to visualize the mean value, maybe a little bit more nuanced. And for my results page, I created an interactive web page that shows 2 different web maps that I made specifically for this project. We can zoom in on the map. We can click on different watersheds and get information. And I have different layers already as a widget available for the user to look through. This relationship layer lets us look at areas with high ratio of cropland to chestnut suitability. So areas that are both existing cropland and are highly suited towards chestnuts, and how related these are to areas that are susceptible to, in this case, wind erosion. And I have a similar analysis for chestnuts and KW fact, or water erosion. I also have another tab where I show ecological index, and this ecological index is from the Wisconsin DNR. It's more abstract, so I just present the data. I don't do a relationship, but I do show count of chestnut suitability and that ratio layer again. So users are free to zoom in, kind of analyze it how they want. We're looking at count of chestnut suitability as dot density. So the user is free to zoom in, see how the density looks at different scales, compare it to different layers. And I give some discussion on the results printed in page.